Okay, in this case, we are asked to rationalize the denominator, which means lose the radicals on the bottom. And the trick that we use to do that is to multiply top and bottom by the conjugate of the denominator. So it means the conjugate is the same thing, okay, top and bottom, except that sign changes. So instead of a plus, this will be a minus. And it's just a trick that we use because when you multiply now, the bottoms, that'll cancel out all the radicals. Let's just try it then. So root 3 times root 3 is root 9. I guess I'm doing the denominator first. Root 3 times negative root 10 would be a negative root 30. Root 10 times root 3 is a positive root 30. And root 10 times minus root 10 is a minus root of 100. Let's do the top two. 7 times root 3. One's in a radical and one's not, so I just have to write that as 7 root 3. And then 7 times negative root 10 would be a negative 7 root 10. Okay, so on the top, let me just leave the top for now. Those 7s are sort of sticking out to me. And then on the bottom, the square root of 9 is 3. Root 30 plus root 30, those cancel. Minus the square root of 100 is 10. So what I have then is 7 root 3 minus 7 root 10 all over a negative 7. So now what I can do is I can take each of those terms up top and divide them by negative 7. So 7 root 3 divide negative 7, and negative 7 root 10 divided by negative 7, because this is a common denominator. So here the 7s cancel, so I'm left with negative root 3. And here the negatives cancel, so it'll be a positive. The 7s cancel, so I just have a root 10. So that would be my final answer. I could rewrite it if you want to have the positive term first. So you could write it as root 10 minus root 3. But both of those are 5 out of 5.